So what we have in here is exercise 7.3. So let's start with question number 1. So question number 1 says, how many 3 digits number can be formed by using the digits 1 to 9 if no digit is repeated? So basically we have done these type of questions in my box method, but here we will not be using box method. We'll try to do it by permutation. So first thing, how many objects are there? Basically permutation was what? NPR, where n is the total number of objects and r is what? Objects taken at a time. So if I have 5 objects and if I have taken 3 objects at a time, then it will be 5p3. Clear? So here they're saying how many 3 digit numbers can be formed by using the digit 1 to 9. So 1 to 9, basically there are 9 digits, and among those 9 digits I have to make 3 digit number. Now in order to make 3 digit number, obviously I need to take 3 digits at a time. So basically the value of n will be 9 and the value of r will be 3. So the answer will basically be 9p3. Clear? So let me write this one. So what we are going to write in here is the number of digits, the total number of digits is 9, and the number of 3 digit numbers formed will be equivalent to the permutation of 9 digits taken 3 at a time. So this is my required thing. So the permutation of 9 digits taken 3 at a time, that will be my answer. So what is it? Therefore the required number is equal to 9p3, and 9p3 is what? It is 9 factorial divided by 9 minus 3 factorial, because we have already discussed this one. NPR is equal to what? N factorial divided by n minus r factorial. So that is what we have. So it is 9 factorial divided by 6 factorial. So if I cut this one, 9 factorial and 6 factorial, if I cut, so what we have is 9 into 8 into 7 and 7 into 6 factorial. So 6 factorial gets cut. So we have this thing, and you multiply and you write the answer. Now the next one, that is question number 2. So this will give you the answer. So question number 2, what we have is, now it's all about the question. You have to read the question very, very carefully in these type of problems. Then in permutations also, the question has to be read very, very carefully. So the question says what? How many 4 digit numbers are there with no digit repeated? It's a very simple question. How many 4 digit number are there with no digit repeated? So nothing has been said. So basically they're talking about numbers. Now how many numbers do we have? Obviously we have 10 numbers, 0 to 9. These are all numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 numbers are there, and we have, among those 10 numbers, we have to pick 4 numbers at a time, and we have to arrange them into 4 digit, right? Clear? So permutation, I told you what permutation is nothing but selection as well as arrangement. So from these 10 digits, I will first select 4 digits, then I will arrange them to form a 4 digit number. So permutation is selection, then arrangement, right? Now here, before discussing the question, I will just go through the basic idea of the question. Now you see, all the 4 digit number which we will form, that will be given by what? There are 10 numbers are there, and we are selecting 4 digits at a time. So it will be 10p4. But there is a problem. The problem is that when you are arranging, when you are making 4-digit numbers, there will be certain numbers which will start with 0. There will be certain numbers which will start with 0, right? Okay, here I made a mistake. It will be 0349. The digits cannot be, no digit repeated, so we cannot repeat the digits. So if I have 0 in the thousands place, so in the thousands place if I have the 0, so obviously this is no more a 4-digit number, this becomes a 3-digit number. Clear? So we cannot accept 0 as my in the thousands place. We cannot accept 0 in the thousands place. So how can I remove all those numbers which has 0 in the thousands place? So now we have to think this one, how to do that. So first thing, we have found out that from the 10 numbers, from the 10 numbers, how to form 4-digit numbers. But here, while we are solving the problem, we came across with a problem. The problem is that the zeros in the thousands digit. So how to remove this problem is, you see, what I will do is, first thing, in thousands place, I am fixing the 0 digit. I am fixing the 0 digit in the thousands place. Now how many numbers remains in my hand? In my hand I have 9 digits, because I have already put the 0 number in here. So 1, 2, 3, 4, 5, 6, 7, 8, 9 are in my hand. Now there are 3 places to be filled. So basically I will be selecting 3 items from this 9, and then I will arrange those 3 items in this place. So basically this problem becomes the problem of having 3-digit numbers from the 9 numbers. It's like the previous one. The number of 3-digit numbers can be from 9 digits, right? So here we have 9 digits, and how many ways we can find 3 digits? We have 9p3. So 9p3 are the total number of numbers we will get which start with the letter 0, and they are not a 4-digit numbers. So what we will do is, I need to remove this. So my answer will be 10p4 minus 9p3. This will be my answer. So let us arrange this one and write it nicely. So what it will be, let us do that. There are total 10 numbers. There are total 10 digits, and to form 4-digit number from them, and to form 4-digit numbers from them, we need to do permutation of 10 digits taken 4 at a time, and that is what? And that is 10p4. So this is what we have, right? So 10p4 ways we can find 4-digit numbers from the 10 digits we have. Now we talked about the problem. So now the problem is what? Now there are certain numbers whose thousands digit is 0, which makes them a 3-digit number. So the number of the 3-digit numbers can be found by permutation of 9 digits. I will fix that 0 digit. 9 digits taken 3 at a time. Taken 3 at a time. So that will be given by what? 9p4, and that is 9p4. Sorry, 9p3. There are 3 places are to be filled. So that is 9p3. So therefore the required answer is what? Therefore the required 4-digit numbers are 10p4 minus 9p3. So you have to calculate this one. So how much you're getting? So it will be 10 factorial divided by 10 factorial, 10 factorial divided by 10 minus 4 factorial minus 9 factorial divided by 9 minus 3 factorial. So that's coming out to be 10 factorial divided by 6 factorial minus 9 factorial divided by 6 factorial. And this one is coming out to be 10 into 9 into 8 into 7. This one is 9 into 8 into 7. So if I take 9 into 8 into 7 common, 9 into 8 into 7 taken common, so we have 10 minus 1. So basically you are getting 9 into 9 into 8 into 7. So you have to multiply and write the answer. So this is how we solve question number 2. Now let's move on to question number 3. So question number 3 is how many 3-digit even numbers can be made using the digits 1, 2, 3, 4, 5, 6, 7, 4, 6, 7 if no digit is repeated. So question number 3, I think we have already done for even numbers in 7.2. So question number 3 will be homework for you guys to try. If you have doubt, then we can discuss that question. Now let's do question number 4. Question number 4 is also an even question. So both of them is quite similar. Even number question. So question number 4 says find the number of 4-digit numbers that can be formed using the digits 1, 2, 3, 4, 5. So there are 5 digits are there, 1, 2, 3, 4, 5. And we have to do what? We have to find the 4-digit numbers with no digit repeated. Now this question is very, very easy. It means what? So we basically have to pick 4 numbers at a time, right? So from these 5 digits, in order to form 4-digit number with no repetition, we just have to pick 4 digits at a time. So basically it is what? 5p4. It is 5p4. Simple as that. So I will write here, therefore the number of 4-digit number is equal to permutation of 5 digits taken 4 at a time. And that is equal to 5p4. So that is 5 factorial divided by 5 minus 4 factorial, and that comes out to be 5 factorial divided by 1 factorial. We know that 1 factorial is 1. So we are getting 5 factorial. And 5 factorial is how much? It is 5 into 4 into 3 into 2. So it is coming out to be 120 into 1. It is 120. Okay. So that's how we got the first part of the question. Now it was very easy. Now the second part is how many of these will be even? So these are the total number of digits we got, total number of 4-digit numbers we got. Now you have to, they have asked you how many of these 120 numbers which we got is even. Now for even, what we need to do is, look at here, if I have a 4-digit number, now think of that box. If I had that 4-digit number, so when my number is even, so this place, the units place, for the number to be even, the units place must be an even number. right? So the units place, how many ways we can fill the units place? Now there are two even numbers are here, so we can fill the even numbers as 2p one way. We can fill the units place in 2p one ways because there is only one compartment is there, one place is there, and there are two numbers are there, that is 2 and 4, so we can fill it in 2p one ways, right? Now one element already used in here, so how many elements do we have? 4 elements. So in this 3 places we need to put 4. So from 4 numbers we have to take 3 at a time, then we have to put those 3 digits in these 3 places. So basically that is what, 4p3, that is 4p3. So once you see this one, the 3 digits are filled in 4p3 ways, and this last unit digit to make it an even number is filled in 2p1 ways. Now by multiplication principle, the required number of even numbers we get is 4p3 into 2p1. So this will be my answer. So let us write down. So for even numbers, the units digit must be an even number. Must be an even number. The units digit must be an even number. So the units digit can be filled in 2p1 ways. We have already looked into that it is filled in 2p1 ways, right? And the remaining digits can be filled in 4 digits remains are there, 4 digits remaining in 4p3 ways, in 4p3 ways. Hence by multiplication principle there are two events, one is the unit digit event and the other one is the remaining digits. By multiplication principle, the required number of even numbers is equal to 4p3 into 2p1, and that is equal to 4 factorial divided by 4 minus 3 factorial into 2 factorial divided by 2 minus 1 factorial. So that's coming out to be 4 factorial. This is 1 factorial, so there is no need to write that one, and this is coming out to 2 factorial. So we are getting 4 into 3 into 2 into 1 into 2 into 1. So that's coming out to be 12, 24, that is 48. So my answer will be 48. So there will be 48 even numbers in there. Now let's do question number 5. So question number 5, what we have in there is from a committee of 8 persons, so there are 8 persons in there, in how many ways can we choose a chairman and a vice chairman, assuming one person cannot hold more than one position? So here there are 8 members are there. Now among those 8 members, suppose there are 2 seats. Basically think of the box method. There are 2 seats. One seat is for the chairman and the other seat is for the vice chairman. And one thing they said that one person can hold not more than one position. So it means what? If I put one person in here, that same person cannot hold this position. The person who is chairman, he cannot be a vice chairman again. Okay, clear? So there are 8 members are there. So how many ways? So basically what? There are 2 positions are there, right? So how many elements, how many people we have to select at a time? So we have to select two men at a time, 2 persons at a time, and among those 2 persons I will have to put them in these 2 positions, right? So first I will select 2%, then I will arrange those 2% in the position of chairman or vice chairman, right? So the value of n is what? Total number of person is what? 8. So the value of n is 8, and the at a time, how many persons we have to take? 2 persons. So r is equal to what? 2. So there were total number of arrangement. So the total number of ways we can select a chairman and vice chairman will be 8 P2. That will be my answer. Simple as that. Am I clear? Okay. So let me. Achha, we are not going to do this question because I hope you can do it. You can please write it down nicely. Yeah. So let's do question number 6. Question number 6. So question number 6, what we have is find n if n minus 1 P3 is to n P4 is equal to 1:9. Question number 5, please solve it. I have shown you like this, but please solve it. And you don't have to write the box form. So you, in question number 5, you just write like that. So we have to do what? The total number of ways is equal to permutation of 8 persons taken 2 at a time. Permutation of 8 persons taken 2 at a time. So this one is coming. We have to find the value of n, right? So let's do this one. So basically we have n minus 1 P3 divided by n P4 is equal to 1/9. This is my question. Now n minus 1 by 3, we can write it as n minus 1 divided by n minus 1 factorial, n minus 1 minus 3 factorial, because we know npr is equal to what? N factorial divided by n minus r factorial. That divided by n factorial divided by n minus 4 factorial is equal to 1/9. This is what we have. Now this is also n minus 4 factorial and this is also n minus 4 factorial. So we can cut these two. So what we have is or n minus 1 factorial divided by n factorial. Now what is this? Basically one is 9 minus 1 factorial and the other one is 9 factorial. So n minus 1 factorial and this one is 9 factorial. So we can do what? So it is like this, 8 factorial by 9 factorial. So we can cut this and we can get 9. So n minus 1 factorial divided by n factorial, we can cut them and we can have n in here. So basically therefore n is equal to, so 1 by n is equal to 1/9. So n is equal to 9. That's how we get to the answer. Okay. Achha, 7.1 will be homework. Let me do question number 7.2. So 7.2 I will do. So what we have in here is 5pr is equal to 6pr minus 1. So you have to solve this one. So let us solve this. 5pr is equal to what? It is 5 factorial divided by 5 minus r factorial is equal to 6 factorial divided by 6 minus r. Now 6 minus r, achha, let me write like this, entire factorial. So or what we have, let's leave it like this, we'll cut at one time. 5 minus r factorial is equal to 6 factorial divided by 6 minus r plus 1 factorial. So now let's cut. So if I cut this one with this one, what I get? Here we get 6, right? So what we have in here is or 1 by, achha, if I cross multiply, let's cross multiply. So we have 7 minus r factorial is equal to 5 minus r factorial. So this is what we have. 7 minus r factorial is equal to 5 minus r factorial. So tell me, what will be it? When can I get this one? 7 minus r factorial is equal to 5 minus r factorial. What are the possible values of r that this one is possible? First thing, this factorial, it can never be negative. Okay, it can never be negative. So which value will it be?